All right, so today we're going to talk about functions and relations. Before we go there, one of the review topics in the back of this section was to graph the linear equation 2x plus 5y equals 20 by finding the x-intercept and the y-intercept. I don't know why this is considered a review topic, because the next section we're really going to talk about this topic. But anyway, to review what an x-intercept and a y-intercept are, to find an x-intercept, you do it by letting y equal 0 and solve for x. So in our equation, if I have 2x plus 5 times 0 equals 20, that gives me 2x plus 0 equals 20. If 2x is equal to 20, when I divide both sides by 2, I come up with x equals 10. You agree? Okay, the x-intercept is a point. So to tell me what a point is, you have to give me a coordinate, an x comma y. The x value is 10. The y value we said was 0. So the x-intercept is the point 10, 0. Let's go do the same thing for the y-intercept. For the y-intercept, we let x equal 0. So 2 times 0 plus 5y equals 20. You're actually solving 5y equals 20. When I divide both sides by 5, I get y equals 4. Again, the y-intercept is a point. To tell me what the point is, you need to give me a coordinate, an ordered pair. The x value is 0, the y value is 4. So now we're going to go graph it. For the y-intercept, 0, 4. Right here. For the x-intercept of 10, 0, I'm going to go like this. So 10, 0 is over here. To graph that line, it looks like that. Questions? This actually starts the material for this section. Determine whether a relation is a function. Some definitions. A relation in x and y is a set of ordered pairs x comma y. A relation in x and y is just a set of ordered pairs. It's a relationship. Somehow you're relating an x and a y. The set of all x values we call the domain, and the set of all y values we call the range. How do you remember that? Do you see that x comma y is in alphabetical order? Domain range is also in alphabetical order. Domain range. DR, x, y. Domain goes with x's, range goes with y's. We good? An example. Write the set of ordered pairs that defines the relation. They give you a table. They give you a list of x values and a list of y values and tell you to go write the set of ordered pairs that defines that relation. So a set looks like this. An ordered pair, give me the first ordered pair. What's the x value? 3. And the y value is? -4. So the ordered pair, 3, -4, needs to be in that set. Give me another ordered pair. -2, 0. There's 2 more ordered pairs. 5, 3, and 1, 0. And I've run out of room, so I'm going to squish it. 1, 0. Okay, that is a set of ordered pairs. It's a relation. It relates x's and y's. What is the domain of that relation? It's all the x values right there. Or if you're looking at the set of ordered pairs, you find the domain right there. So the domain is 3, -2, 5, and 1. It's a list of numbers. Do I need to put that list in chronological order? You don't have to. Most books will, so you'll see it as, what is that going to be, -2, 1, 3, 5, if you want to list it in order. Okay, the range, what is the range? All the y values. If I list them in order, I'm going to have -4, 0, and 3. Do I need to list 0 twice? No. Just list it once. Okay, I'm going to look ahead because I know what's coming. I'm also going to show you that you can do this relation in what's called a mapping form. So I'm going to put all the x's over here. 3, -2, 5, and 1. List the y's over here. And I can do an arrow. 3 goes to -4. -2 goes to 0. 5 goes to 3. And 1 goes to 0. This represents a relation. That's called a mapping representation. When you're giving a mapping, could you tell me what the domain is pretty quickly? It's this, right? The range is over here. Okay, so a relation in x and y is just a set of ordered pairs, x's and y's. Now we're going to talk about a function. If you're given a relation in x and y, we say that y is a function of x if for each value of x in the domain, there's exactly one value of y in the range. That's a fancy way of saying the x's do not repeat. The x's do not repeat. So to be a function, first of all, it has to be a relation. And then it has a special condition on it that the x's can't repeat. So here's a true-false question. Every function is a relation. Is that true or false? Every function is a relation. To be a function, what do you have to be given? You have to be given that it's a relation. So is every function a relation? Yes, so that first one is true. Second question, every relation is a function. That one is false. So the question is, if I give you a relation, is it a function? So here we go. How to determine if a relation is a function.